Hey everybody, it's Mr. Carr again. Today we're going to be talking about 9.4 ellipses. So this is a nice little, well, it's a very blurry image, but there's a nice quick demonstration of what an ellipse is. It's basically an oval shape. So when we look at the planets as they orbit around the sun, it's an elliptical, it's an elliptical orbit. Okay, so it's not a perfect circle, it's doing a oval shape. So our goal today is trying to understand how to model those things. Okay, here's the standard form for an ellipse. Ellipse is always going to be equal to 1, no matter what. Okay. What we get is kind of a horizontal orientation in this case, which means it's kind of an oval shape that goes more this way, or a vertical one that goes this way more. Okay, that's what we're saying. X squared over a squared plus y squared over b squared, y squared over a squared plus x squared over b squared. The a squared and b squareds, the thing to remember about that is that a is always larger than b. So what I like to look at is the larger number, if it's under the x squared, means it's going to be this horizontal orientation. But if the larger number is under the y squared, that's what gives us our vertical orientation. Okay. The a and b, that kind of also helps us figure out what's called the vertices and the co-vertices. That's what you see here. Okay, A is always going to be used for the vertices. So it's going to go here and here for the major. Okay, and it's going to go here and here when it's like that, vertical like that. The B value is going to give us our co-vertices. So I should say this is the vertex, co-vertex, and then co-vertex. Okay, so the co-vertex, that's what's called the minor axis. Okay, and then the major axis is again going to the vertex. When we look at the total length of each of those, so the length of the major axis says it's 2 times a. And again, the reason why is because if a goes here and I go to another a that way, the whole length is 2a. Same thing going this way. That's b, that's another b. So the whole length is 2 times b. Okay, so that's just thinking about that length idea there. So how does a squared, and I forgot to mention the last part, which is the foci. So there's a focus in both directions here. So this is a focus, and this is a focus point. Oops. I hope I spelled that correctly. Focus. All right. That point, what we get is this kind of relationship here that looks a lot like Pythagorean theorem. And that's because it technically is a Pythagorean theorem. Yes, it's not a squared plus b squared equals c squared, but here's kind of the model. If I draw this line here, okay, I am creating this right triangle with my major and minor axes. I get a length here of b and a length here of c. What the relationship is that a is the same length as this a. So that's what, it's almost like taking this right here. It's kind of weird, but if I take, all right, if I take this and I kind of like shift this point up, but it's a fixed length. So what happens is that this point is shifting up here. This point only just kind of moves here because of the way it moves on a diagonal like that. Okay, so that's where we're getting those values from. So in our scenario here, when we try to model some of our ellipses and graph them, that's what's important. Okay, vertices, co-vertices, and foci. That's what we're looking at. Okay, so remember, the vertices here, this is my major axis because it's the larger number, which is on the x. Okay, so the graph of this ellipse is actually going to start at the 0, 0 here. If a squared equals 25, and I square root this, that means a is equal to a plus or minus 5. From the center of 0, 0, I'm going to go 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 to the left. Okay, there's my vertices. So I'll just put it as a V and a V for now. Okay, so I get negative 5, 0 and 5, 0. For my co-vertices, from this one right here, b squared equals 9. So if I square root that, b is equal to a plus or minus 3. So I can go from the center, 1, 2, 3 up, 1, 2, 3 down. You already see what the ellipse is looking like. So these are my co-vertices here and here. So I just call it CB down here too. So that's 0, 3 and 0, negative 3. Okay, and the last thing is the foci. So remember that a squared is equal to b squared plus c squared in this case, because what it's making is it's making like a right triangle that goes kind of like right here, roughly like that. So that's the c there. So c is a leg. So instead of doing that, I'm going to write c squared is equal to a squared minus b squared. Might make it a little bit easier because now I can just do this. C squared is equal to 25 minus 9, which means I get c squared is equal to 16, and I square root both sides, so I get plus or minus 4. So what that means is, again, that's going to go the same direction as the major axis. Foci is always on the major axes. So I can go 1, 2, 3, 4 here, 1, 2, 3, 4 here. Here's my focus and focus right there. So just to get my little oval shape, as long as you have all your vertices, covertices, and label the foci, that's what we're looking for a graph. So this is a good horizontal one. And again, that's because the 25 larger number is under the x squared. It goes horizontally. Here's one that's going to go vertically because 36 is under the y squared. Okay, I still want to treat it as a squared. So a squared equals 36. So I square root that. So a is going to be 6. B squared equals 4. So I square root that. And I get, sorry, plus or minus 2. So that means my vertices are at, it's going in the y direction. So I'm going to go 0, 6, 0, negative. Oops. Very messy there. 0, negative 6. And then the co-vertices, I'm going to go 2, 0, and negative 2, 0. Okay. Again, the center is at 0, 0 because it's just x squared over y squared. So I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then 1, 2, and 1, 2. So I have enough to graph the actual ellipse, but just to have the foci, I'm going to do c squared is equal to a squared minus b squared. So in this case, it's going to be 36 minus 4. C squared equals 32. So if I square root that as an exact value, I can break that down. That's going to be 4 radical 2. Okay. So that means my foci are going to go in the same direction as my major axis. So it's going to go up and down. So then in this case, it's going to be, whoops, come back here. Okay. It's going to be 0, 4 root 2. And 0, negative 4 root 2. When I estimate that on the graph, it's going to be, let's see here. It's going to be a little bit more than, it's going to be a little less than 6. So honestly, it's going to be like probably a little bit past the 5 marks on here. Okay, so that's the foci and the foci there. But then everything else is good for my ellipse. Okay. All right. Here, we're just going to write the equation given some information. So if I have the vertices at negative 6, 0, 0, and 6, 0, co-vertices as 0, negative 4, and 0, 4. So again, the x values are the vertices. So that's the major axis. So I'm going to put x squared. Well, let's do this. The major axis is at negative 6 and positive 6. So that means my center is at 0, 0. Okay. So I know it's going to be an x squared and a y squared over something. Okay. This is kind of like the general format. In this case, a squared and b squared will be here because we have the major axis, the vertices are going the x direction. So since a is equal to 6 in this case, I can square both sides so that a squared is equal to 36. If b is equal to 4, I can square both of those, so I get b squared equals 16. So that's what goes under the x squares and y squared. So x squared over 36 plus y squared over 16 equals 1. And that's it. We're just using, again, the definition of vertices and co-vertices to help us get our equation. All right. This is going to be this, I'm going to go ahead and skip this one. Let you try it on your own. Same exact thing, but now y is the major axis. So we're just going to kind of swap that idea. Okay. Because I want to get to one more example. Yeah, one more example that's a little bit trickier. We're going to use completing the square again, but it's going to look a little different. So find the coordinates of the center and foci and the lengths of the major and minor axes of the ellipse, and also graph the ellipse. So just like before, I'm going to rearrange this. So x squared minus 6x plus blank. Then I look at this one. I got 4y and 16y. With that completing the square, if you remember from before, I'm actually going to factor out a 4 out of both of those. So it's going to be y squared minus 4y plus blank. Okay. I'm also going to add the 11 to both sides right away automatically. Oops. Didn't want to write that there. That equals 11. Okay. And now for my completing the square process, I've got -6 divided by 2 is a -3. And then -3 squared is 9. So I can put a +9 here. Over here, I've got -4. So -4 divided by 2 is a -2. -2 squared is a +4. So I'll put a 4 here. This time, though, here's where some of the challenges. Because of the 4 that I had to factor out originally, I'm going to add the 9 still to both sides, but I'm not going to add 4 here. I need to do 4 times 4. So I'm going to add 16 to both sides. It's a little bit goofy, but that's the idea here. Now, again, by completing the square process, I'm going to go ahead and complete the square for both the x's and the y's. So x squared minus 6x plus 9 is going to factor into x minus 3 squared. 4 times y minus 2 squared gives me my completing the square there. 11 plus 9 is 20, plus 16 is 36. Standard form of an ellipse. This is kind of like with our circle process, but instead of it equaling 36, it has to equal 1. Every time we do an ellipse, it needs to equal 1. So everything just gets divided by 36 in this case. Nothing is going to change for the first part here. So x minus 3 squared over 36. But 4 and 36 can actually reduce a little bit. So I get y minus 2 squared over 9. And then I get equal to 1. You haven't seen an ellipse like this, but here's just like with our circles, this is going to be my center. My center is going to be the opposite of the -3 and the opposite of the -2. So I'll plot that as my first point. So 1, 2, 3, 1, 2. Okay. Just like before, my major axis is right here. So a squared equals 36. I square root that and I get plus or minus 6. B squared is equal to 9. So I get B equals a plus or minus 3. From the center point, that's where I'm going to move in my major and minor axes. The major is in the x direction because 36 is under the x's, and then the minor is in the y. So I can go in the major direction. I'm going to go plus or minus 6. I'm going to go 1, 2, 3, 4, 5, 6 out here. And 1, 2, 3, 4, 5, 6 over here. For my co-vertices, I'll go 1, 2, 3, then 1, 2, 3. Okay. So I have enough to graph it. It doesn't ask for the foci in this case, so I'm just going to skip that for now. Ignore that bell. Okay. But it does say to find the length of, oh no, it does say find the coordinates of the foci. My bad. So for the foci, we're going to do this as, we're going to do c squared is equal to a squared minus b squared. So c squared is equal to, this will be 36 minus 9, which is going to be 27 for c squared. And I square root both of those. So I get, that's going to be 3 root plus or minus 3 root 3. Here's where it's a little bit tricky. We are going to add that to the x value that's in the right here. So we're going to subtract x, add x here. So it gets a little bit tricky with the way that looks, but it's going to be complicated with that 3 root 3. So from the center point of x3, it's going to be 3 plus 3 root 3 comma 2. And 3 minus 3 root 3 comma 2. Okay. So yeah, it's tough to kind of estimate on my little graph here, but that's the idea. Use your calculator, get the decimal answer to kind of get an estimate where the points were. But I have enough to graph it because I have my center and I have my 2 vertices and 2 co-vertices. The last thing to talk about is just the length of each of the major and minor. Remember, the plus or minus 6, that means my major axis has a length of 12. I just plus 6 and minus 6, that's a length of 12. Okay, or it's 2 times a, I should say. The minor axis has a length of 6, because we just take 2 times 3. Okay, really straightforward on the lengths of each of those. All right, that's it for ellipses. It's a lot to do with this, but it's a lot of graphing, a lot of understanding, and we're still actually get to do completing the square. So it's a lot of fun with that kind of algebra. All right, but that is it for 9.4. All right, take care, everybody.